Hey guys, so today I'm going to be doing a tutorial on how to do Euler's method. So Euler's method is basically using tangent lines and the delta x and delta y to approximate values on a curve, on a derivative curve. So basically linearization. If you have taken it, this is something you take in AP calculus. So I'm just going to be doing a differential equation here and solving points using Euler's method. So basically, Euler's method is first you have your given point, which in this case is 0, 2. What I have, so I have my x value here, 0, right here, right? And then my y value, original, is 2. So that's how I'm going to do a 2 here, okay? So now basically what you do in the third column is you plug in your coordinates into your derivative equation. So here I have negative 2x divided by y. So I plug in negative 2 times 0 divided by 2, which in this case would be 0. So my slope is 0. So now I would find delta y, how much y changes every time my delta x, which is 0.1, every time my x changes. So I would have to find how much my y changes also. So right here, I would multiply the slope times the delta x, which in this case is 0.1, as you can see here, adding by 0.1 each and every time. So 0 times 0.1 would be 0. So this is easy, right? Now basically what you do now, to find the next y coordinate here, you would add this number here times the original number here, and then get it this next coordinate here, okay? So I'm doing a couple of coordinates so you can see exactly what I mean right now. Okay, so 0 plus 2 would equal 2. Now I'm going to plug in 0.12 into the equation above. So that's negative 2 times 0.1 divided by 2. So that's negative 0.1. And you can always use your calculator to check it out. So that's what I'm going to do right now. Hold up. Wait a minute. Yeah, negative 0.1. Okay, now what I'm going to do is I'm going to multiply my delta x times my slope. So now 0.1 times negative 0.1 is negative 0.01. 1/10 times 1, negative 1/10 is negative 1/100th. Okay, now what I'm going to do is I'm going to add this number to this number to get the new number. So 2 minus 0.01 is 1.99. So that's my new coordinate for when x equals 0.2. Okay, so now I'm going to plug in 0.2 comma 1.99 into my equation. So I have negative 2 times 0.2 divided by 1.99. So I get about negative 2.01. Wait, just kidding. Forget about that. Negative 0.201005. Okay. Now I'm gonna multiply that number by my delta x. So when I do that, I get negative 0.20101. Okay, and you can always round, but I feel that using more decimal places will give you a better approximation of exactly what you're doing. What you're doing right here. So now I'm going to multiply this number by my delta x, and then I'm going to get about 1.9699. If you want to round it to 4 digits, you have a better approximation. Now, since I don't have any more points, I don't need to do this, because doing these next two columns would approximate my next point. But if you want to, for additional practice, you can. So I'm just going to do it. If I plug in the values for this, I get negative 0.203056. And then if I do this column, I get negative 0.020306. Sorry for my messy handwriting, guys. I'm sorry. That's a negative 0.020306. So now if I wanted to find point at x equals 0.4, I would just multiply this number times my delta x, which is 0.1, and then I would have my new y coordinate at x, approximate y coordinate at x equals 0.4. Okay, so that's basically Euler's method. You're basically approximating the values. Now if you want to find the real value, see how much you like differed off from the original value, then that would be solving differential equations. So that's what I'm going to do right now. So we know that our differential equation is the equation negative 2x divided by y at the point 0, 2 with a delta x of 0.1. So what I'm going to do is use integrals right here. So first we have to separate the variables. Now you can only separate the variables by dividing or multiplying. So if I had x plus y, I couldn't equals dy over dx. I couldn't do that because to separate the variables, I'd have to get the x and y on both sides. So x and dx have to be on the same side, y dy on the same side. But to do that, I'll have to subtract or add. So that wouldn't exactly work out. So for this, it would work out. So what I'm going to do is multiply y up to both sides. So I get y dy. Okay, now I'm going to multiply dx to both sides. So I get negative 2x negative 2x dx. Okay, now I'm going to take the integral of both sides. So basically, when you're like anti-differentiating and you have already derivative, think of this as being like 1 kind of. So it'll make it kind of easier to differentiate on some equations. So when I anti-differentiate this, I'll get 1/2 y squared this side. So if you do the derivative of this side, you'll see you get y, and then derivative inside you get dy. So y dy right here. For this, I'll get negative x squared plus c. So basically negative x squared, derivative is negative 2x. C is basically some other point to find your original equation, because the derivative of this number would be 0, so it will still fit in with this. So you're basically just trying to find c. Okay, now we also, to solve this, we have our given point at the beginning 0, 2. So when x is 0, y equals 2. So we can plug that into our formula here. 1/2 times 2 squared equals negative times 0 squared plus c. So this all cancels out. So you have here 4 divided by 2, which is 2 equals c. So we know c equals 2, right? So we can plug this into our equation right here. So 1/2 y squared equals negative x squared plus 2. Okay, now we just have to solve for a decent y equation. So multiply both sides by 2, you get negative 2x squared plus 4. Okay, basic multiplication. Now if you find the square root of both sides, you'll get y equals plus or minus square root of negative 2x squared plus 4. Plus or minus because it's square root. Now, to decide whether you want the plus or the minus of the square root, you'll have to look at your original point. So when x is 0, y is positive, right? So we don't want the negative sign out here. We want the positive sign because y is positive out here. So that's why we would use the positive sign. So it'll be y equals positive square root of negative 2x squared plus 4. So that would be our y equation. Now we approximated approximately what each point is right here, right? So if you want to see like how much off you were, you can plug in those x coordinates into your y equation. So I'm just going to plug in 0.1, 0.2, and 0.3 just to see like how far off I was and how reliable Euler's method can be. So just going to plug that in right here to my calculator. Negative 2 times 0.1 squared plus 4. I get 1.994994. So that's approximately 2. So you see this is a pretty good approximation of it. So I'm going to do 0.2 now. Negative 2 times 0.2 squared plus 4. I get 1.979899. Okay, now see how this one was less than 0.1 away from the approximated value. We can see that this one's approximately like 0.2 away. 0.2 away. So you see, as the number of x value gets away from the original starting point, the approximations can start to differ a little bit. And I'll show you how, like plugging in 0.3 as a value. So here I get 1.9544. Okay, so now see how it's differing kind of a bit. This is about 1.97, 1.95. So it's kind of differing here. So I'll just show you like what I mean later on. So if I plug in 0.6, I'll get 1.856 as an approximate value here, right? 1.856. But if I plug in 0.6 here, I'll get 1.811. So you see how it's kind of like the distance between the approximated value and the calculated value is kind of increasing as you go farther away from the original point. So that's how you have to keep the like intervals closer together. So here I did 0.1, you can also do 0.2, but then it'll be like greater intervals and the approximation will be a little off as the number of intervals increases. But you can always like reduce your intervals. Also remember, when differentiating or solving a differentiable equation, you can only multiply or divide. You cannot add or subtract here. So that would be unsolvable unless you use a slope field, which we'll talk about in my next video. So thank you guys for watching. This is my video on how to use Euler's method and how to solve differentiable equations. Keep up the support by subscribing, guys, so I can post new videos on calculus work, anything you might need. If you need any help with any calculus work, feel free to comment down in the comment section below, and I will try to make a video as soon as I can. Also, don't forget to check out my other channel. I'll post the link in the video below, in the description below, so you can check that out too. Thank you guys for watching, and good luck.